Hello friends, welcome to Electronic Circuit Hub. So in the high speed design tricks series, today we are going to understand about the Via Stub. This is the seventh video of this series. So if you haven't watched the previous video, please go and watch the video. Okay. So today I am going to discuss about the basics of Via Stub and how it plays an important role in the signal integrity, right? So let us see what is the Via Stub, right? So when a routed signal start from top layer and end with inner layer, then the remaining portion of inner layer to bottom layer is called Via Stub. So you can see this image here where you can see one signal is coming from here, and let us say this is top layer, and it is going to in the inner layer. So this is inner layer. Okay, so this is called via, and the remaining portion of this via. Okay, so let's say you have drilled from here to here, from top to bottom layer, but you are using your signal from top to one inner layer, and there is no signal traveling from your top to bottom layer. So this portion is left. Okay, so this is called stub. Okay, this is called stub. So so let us say a via stub is a part of via which is not used for the signal transmission. As I have already explained to you that this part of via is not used for signal transmission. That is why this is called stub. Okay, and what is the impact of via stub? Okay, what is the impact of via stub? So a via stub acts like a resonant with a specific frequency at which stores maximum energy within it. If the signal has significant component at or near that frequency, that component of the signal will be heavily attenuated due to energy demands of the via step at its resonant frequency. So basically this via step creates a signal integrity issue, and it attenuates the amplitude of the signal. It attenuates the amplitude of the signal because of the resonance. Okay, so let me go more about the via stub. Let us say this point is C1. Okay, let us say this point is C1 and this is C1, let us say, and your one signal is traveling from like C1. One signal is traveling from C1, so you can see your signal is traveling from here C1, and let us say this is arrow mark here, and here this is the top layer, this is the top layer. Okay, right, this is the top layer, and you have a via from this top layer to inner layer. So this is inner layer, right? This is top layer and this is the inner layer. So your signal is traveling from C1 and C1, and there is a via from top to inner layer, and your signal is going towards C, and let us say this point is C and your signal is going towards here, and so this is our objective. But you have, since you have complete via from top layer to, yeah, bottom layer, so you have the via from top layer to bottom layer, but this portion of your via is not being used, right? Is not being used from here, this is not being used. So this is called via stub. So if a signal is traveling from C1 and it goes to C1, so some portion of your signal goes to C1 and some portion of your signal travels here, right? Travels here. So what happens here? since there is no electrical path from bottom layer to anywhere, so it travel back again to uy, again to the point c1, and some of energy goes to c1, and rest of the energy reflect back to the source, rest of the energy reflect back towards c1. So this is a uh, back and forth mechanism where you can see there is a signal swing, and there is a attenuation in the signal as well. Okay, there is a heavily attenuation due to the resonance. So how resonance creates? Because of signal is swinging from here, from bottom layer again to the point Cn. So there is a swing of signal, and because of the parasitic inductance and the parasitic capacitance, it creates a tank circuit, which 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 is having LC tank resonance circuit, and it store the maximum energy, and it can attenuate the your source signal. Let us say here is your source signal, so it can attenuate your source signal, right? So hope you understand the at least what is the Via step and how it deteriorate the signal and what is the impact in the signal integrity. So in the next video, I will be discussing more about the Via step and how will you calculate the resonant frequency, how will you calculate the stub length, and